Before I continue, I want to make one important comment to contrast the message-based and the shared memory-based approaches to IPC. The end result of both of these approaches is that some data is transferred from one address space into the target address space. In message passing, this requires that the CPU is involved in copying the data. This takes some number of CPU cycles to copy the data into the channel via the port, and then from the port and into the target address space. In the shared memory-based case, at the minimum, there are CPU cycles that are spent to map the physical memory into the appropriate address spaces. The CPU is also used to copy the data into the channel when necessary. However, note that in this case, there are no user-to-kernel level switches required. The memory mapping operation itself is a costly operation. However, if the channel is set up once and used many times, then it will result in good payoff. However, even for one-time use, the memory-mapped approach can perform well. In particular, when we need to move large amounts of data from one address space into another space, the CPU time that's required to perform the copy can greatly exceed the CPU time that's required to perform the map operation. In fact, Windows systems internally, in the communication mechanisms they support between processes, leverage the fact that there exists this difference. So if the data that needs to be transferred among address spaces is smaller than a certain threshold, then the data is copied in and out of a communication channel via a port-like interface. Otherwise, the data is potentially copied once to make sure that it's in a page-aligned area, and then that area is mapped into the address space of the target process. This mechanism that the Windows kernel supports is called local procedure calls, or LPC.